My PhD research was committed to solving the mystery of how to adopt the forces of nature in order to arrange nanoscale objects into complex microarchitectures. With this ability in hand, I then used swarms of tiny particles to make miniaturized devices that can smartly adapt their structures to absorb, bend, or deflect light unlike any other. Because these devices are grown instead of carved, their fabrication saves time and labor, therefore having the potential to change the traditional nanofabrication methods. To put things in context, I use geometry-inspired chemical principles to create order in organized nanoscale materials. Specifically, I use sequence-defined short DNA strands as glues to bond inorganic nanoparticles together. Our advanced synthetic capabilities allow these nanoparticle building blocks to have precise shape and size control down to the single-digit nanometers. And the assembled nanoparticle superlattices can then be used as optical metamaterials to realize a wide variety of exotic optical functions, such as tunable absorbers, anomalous reflections, unnatural refractions, etc. I believe the fundamental studies of organized nanoscale materials have provided a broad library of nanomaterials where their arrangements and compositions can be precisely tailored. Now that we're also able to decipher the ways to control the nanoscale organization processes, the necessary next step is to systematically study the structure, function relationships of these special nanomaterials. The ultimate goal of this field, in my opinion, is to inversely design the synthesis of functional nanomaterials from the bottom up, in order for it to exhibit target physical properties that we have long desired. Now that I have earned my PhD degree in chemistry at Northwestern, I am pivoting to mechanical engineering at Caltech to study architected materials at a drastically different scale. Hopefully in 10 years from now, I can become professor of material science and engineering at the university, serving the role of material architect, dedicate myself to the understanding of how order can be created in material across length scales, and more importantly, how order can be leveraged to build novel materials with functions that surpass as many people's intuitions. I plan to attend as many RMS conferences as possible. On the one hand, to communicate my latest research with many related fields, and more importantly, get inspired by the numerous talented researchers at the cutting edge of material science and engineering.